Hello friends, I am Professor Darshan B.Thakur from Terna Engineering College, Dharashiv welcomes you on my YouTube channel for this subject head digital communication. As far as our today's session is concerned, so we will try to learn this another pulse modulation scheme whose name is nothing but adaptive delta modulation, right? So before going to start our today's session, do not forget to subscribe this channel in order to know the future updates belongs to this digital communication technique, right? So let us quickly go through the objective of this today's session, right? So as you can see, the name given to the technique is nothing but what? Adaptive delta modulation, right? So first question arises in our mind ki why we are going for this adaptive delta modulation scheme over the previous pulse modulation scheme whose name is nothing but what? Delta modulation. So as far as this delta modulation is concerned, so already we had discussed this technique whose name is nothing but delta modulation. So another name given to this delta modulation is nothing but what? It is the one bit quantizer basically. Means in order to improve the signaling rate or in order to effectively utilize the transmission bandwidth, what this delta modulator will try to do? It will try to replace each and every sample with the help of either binary 1 or binary 0. Means instead of encoding each and every sample with the help of finite binary number bits, here each and every sample is being encoded as a 1 or 0, right? This is the basic logic behind this delta modulator. Now as far as this adaptive delta modulator is concerned, it is nothing but what? The transmitter, and this is nothing but the receiver of this adaptive delta modulation scheme. The transmitter is just exactly similar to the transmitter in case of this delta modulator, right? So as you can see here, we are having this one bit quantizer, and here we are having this predictor. Another name given to that predictor is nothing but what? It is the delay circuit basically. So as you can see, before going for this working phenomena of this adaptive delta modulation, first of all we need to understand why we are going for this adaptive delta modulation scheme over the delta modulation scheme, right? So answer for this question is very simple, as we are very much aware of this thing ki in case of delta modulation we are heading through the two different types of distortion basically. Now let us quickly go through the reason behind this key why we are going for this adaptive delta modulation scheme, right? So as you can see, in case of delta modulation scheme, the continuous time signal is being mapped with respect to this step signal, and each time the step size is being either incremented or the step size is being decremented. Means in case of delta modulation, this step size is being denoted by this abbreviation called as a delta. The step size is fixed. Either it is being incremented by plus delta or either it is being decremented by minus delta. It depends upon the output of this first comparator, right? Means see, if suppose this is the step signal, so initially when this step signal is being greater than this continuous time signal, so at that time what will happen? The quantizer will come to know as the difference is negative, so the step size is being decremented, right? Or if the difference is positive, then step size is being incremented. But it has nothing to do with we people. Our area of interest is what? Whenever we are having such type of highest degree of slope in case of this continuous time signal, so at that time what will happen? This staircase approximated signal will falls behind this continuous time signal. So at that time this step signal is not able to follow the envelope of that continuous time signal. Such type of distortion can be called it as a slope over load distortion, right? This is the first reason why we are going for this adaptive delta modulation, right? So first type of distortion which occurs in case of delta modulation is nothing but slope over load distortion. Then another distortion that can be called it is as a granular noise. Now the question arises, at what time this granular noise will occur as compared to slope overload distortion. Slope overload means what? The step signal is not being able to follow the envelope of this continuous type signal, right? Now in this latter part, when the nature of that continuous time signal is almost constant, right? So even for this constant nature, the step size is being deviated by an amount of plus delta or minus delta. Such type of distortion can be called as a granular noise, right? So in order to eliminate these two distortions in which the step size is fixed, either plus delta or minus delta, right? So according to the variations of this continuous time signal, the adaptive step size is being selected in case of this adaptive delta modulation. Okay, so after going through the objective behind this adaptive delta modulation, that is nothing but to avoid the slope overload distortion and granular noise which was occurring in case of this delta modulation, the adequate step size is being selected, right? Means the step size is not fixed in case of this adaptive delta modulation. So let us quickly go through the transmitter and receiver of this adaptive delta modulation, which was just exactly almost 70 to 80% similar as compared to the delta modulation transmitter and receiver. So let us quickly go through with this first comparator. So this comparator consists of these two inputs, x of NTS and x cap of NTS. So x of NTS, it is the unquantized sample signal which was given by that sample and hold circuitry, and as far as this x cap of NTS is concerned, so this x cap of NTS is nothing but it is the approximated signal, means present approximated signal or the past approximated signal, and the difference in between these two signal is being encoded by this first comparator, whose output is nothing but what? E of NTS. E stands for what? The error signal, either it is plus or minus, which depends upon the which signal level is being greater, either x of NTS or x cap of NTS, right? Then the E of NTS is being given to this 1-bit quantizer. So basically 1-bit quantizer will, what it will try to do, it will try to encode the difference in between unquantized sample signal and the predicted value in terms of plus delta or minus delta, which is to be encoded as a 1 or 0. Now let us quickly go through the functionality of this block, whose name is nothing but what? The decider logic to select the appropriate step size. So basically which operates upon the output of this quantizer. So how it operates? So for that purpose, let us quickly go through the signal representation, in which, as you can see, in this portion or during that much amount of time, clearly we can say that the slope of this continuous time signal is very high, right? So basically what will happen during this period, during this first signaling interval, this is nothing but what? The step size or the step signal is being compared with this continuous time signal. As it is lower, so step size is being incremented like this. If it is incremented, so incremented means what? That increment operation is being encoded as a binary 1, right? Now as its name indicates, it is the adaptive delta modulation. So according to the slope, it will try to adopt the desired step size, right? The step size is not fixed here, right? If the output of quantizer is being encoded as a 1, so as a result of this, by an amount of double fraction, the step size is being incremented, right? In order to follow the highest degree of slope of this continuous time signal. Then again one more time, as this is step signal is greater, so again it is being incremented, and that increment operation is being also encoded as a 1. Then after that, as it is greater than this continuous time signal, so it is being decremented, right? Again one more time it is being decremented, and so in this way the slope overload distortion is being removed. And as far as this granular noise is concerned, so according to this continuous time signal, the lowest step size is being selected, right? So either highest step size is being selected and the lowest step size is being selected. It depends upon the output of this quantizer, which is to be read by this basic block, whose name is nothing but what? The step size decider block, or the basic logic in order to decide the highest step size or the lowest step size. Then after that, as far as this lower portion is concerned, so how it operates in order to generate the delayed signal. Here these two signals are being added with each other. Which two signal? The output of this quantizer and the previous predicted value to generate the present predicted value. In this way, this transmitter works in order to eliminate the slope overload distortion as well as granular noise. Right, as far as this receiver is concerned, so again which was exactly just similar to the delta modulator receiver. In case of this delta modulator, we used to have the decoder. What the decoder stands for? The decoder will try to decode the quantized sample signal. After that, those are being added for one more time. So as you can see, in case of this ADM receiver, there are two parts, right? So out of that two parts, first of all, we need to understand what kind of input is being received at the receiving end of this ADM receiver. So as you can see, this receiver receives the sequence of ones and zero. Those are being emitted by this ADM transmitter, right? So the working of this receiver or the decoder is being divided into two different parts. Out of that two parts, first part involves the generation of desired step signal, right? So one question arises in our mind, how these desired step signals are being generated, right? So to have the desired step signal, those step signals are being recovered from the received symbol sequence of ones and zero. Means just similar to the transmission process. The present and past sample values are being added with each other to generate the desired step signal, which is given to one of the input of this comparator, right? So again, this comparator works as an adder. So first input of that comparator is nothing but the step signal, right? The output of this comparator is being given to one of the input of this another adder here, right? To generate the or to develop the envelope of the staircase approximated signal, right? Once that envelope is being generated, then after that this desired envelope of staircase approximated signal is being passed through this low pass filter, whose cutoff frequency is exactly equals to omega hertz, which is nothing but what? The maximum signal frequency component which is present within the envelope of this continuous time signal, which was given to the input of the sample and hold circuitry, right? And the output of this sample and hold circuitry is being given to one of the input of this comparator in case of ADM transmitter, right? So as far as this ADM receiver is concerned, so what kind of role is being allocated to the ADM receiver to successfully reconstruct the envelope of that continuous time signal, which is being passed through this low pass filter, whose cutoff frequency is exactly equals to omega hertz. Before this low pass filter, we used to have this type of accumulator. So basically this accumulator is responsible to generate the staircase approximated signal, which consists of either ones and zero, either plus delta or minus delta, the variable step size. And to have the desired envelope of this staircase approximated signal, we should have the step signals. Those are being generated within this first part from the past and present sample. So this is how this slope overload distortion and granular noise is being eliminated in this adaptive delta modulation. That's why the name given to this technique is nothing but adaptive delta modulation. The adaptive step size is being selected by this ADM transmitter and receiver to overcome the disadvantages of this delta modulation scheme. Thank you. And one more thing, friends, do not forget to subscribe my channel for this subject here, digital communication as well as control system engineering. Thank you.